What if the world you trust, its warmth, its seasons, its gentle balance, was never meant to last? Welcome back. Tonight, we step into a question that has haunted scientists, historians, and dreamers alike. Is the Earth we know merely an intermission between ages of cold? Look around you. The ground beneath your feet, the mild air brushing against your skin, the familiar world framed by your window. It all feels permanent, dependable, almost designed for us. We live our entire lives on an assumption that Earth is supposed to be warm, green, and kind. But that assumption is a fragile illusion. If you were to pull back from this moment, if you could stretch the last million years across the canvas of a single human gaze, you would not see a planet of sunlight and gentle breezes. You would see a world ruled by ice, not confined to distant poles, but rising like colossal, moving fortresses that swallowed North America, Europe, and Asia beneath walls 3 kilometers high. For almost all of human existence, Earth was not a cradle. It was a battlefield between cold and less cold. The Ice Age did not die. It merely rolled back, retreating into the far shadows of the Arctic and Antarctic, biding its time. The glaciers are not gone. They are waiting for a signal, for a shift, for the next beat in a rhythm older than civilization itself. And tonight, we listen for that rhythm. Hidden deep in the darkness of space is a pattern, a cosmic metronome that marks the rise and fall of oceans, the birth and burial of climates. Every 100,000 years, like a slow, deliberate heartbeat, the planet freezes and thaws. This is the enigma of the Milankovich cycles, the story of the silent gravitational choreography that determines the fate of every living thing. A tale written in orbital mechanics, solved by a lonely prisoner who unraveled the Earth's secret clock while the world outside was consumed by war. Tonight, we trace the gears of that celestial clock. We stand where ice once crushed continents. We look upward to the sky to understand how a tiny tilt, a gentle wobble, a barely perceptible shift can turn a paradise into a wasteland. Before we begin, take a moment to like the video and subscribe only if you truly enjoy the journeys we take here. And as always, tell me in the comments where in the world you're watching from and what time it is for you. It's one of my favorite things, seeing this little community gather from every corner of the earth. Now, dim the lights. Let the room settle. Perhaps switch on a fan for that soft, distant hum. Our journey begins right beneath your feet. To find the rhythm of the past, we must go to the quietest place on Earth. We must travel to the dead center of the Antarctic plateau. Here at the Russian research outpost of Vostok, the temperature can drop to minus 89 degrees Celsius. It is a place so cold that breath freezes instantly and falls to the ground as ice crystals. It is a white, featureless void that looks the same in every direction. But the true value of Vostok is not what lies on the surface, it is what lies beneath it. Under the boots of the scientists stationed there lies a sheet of ice nearly 4 kilometers thick. This ice is not a monolith. It is a library. Snow in Antarctica does not melt. It falls year after year, layer upon layer. As new snow accumulates, Its weight presses down on the old snow beneath it, compacting it, squeezing it, until it transforms from fluffy white powder into hard, blue, transparent rock. This process traps something precious. As the snow turns to ice, it captures tiny pockets of air between the crystals. When the ice solidifies, those pockets are sealed off forever. They become microscopic time capsules. They are samples of the Earth's atmosphere from the exact moment the snow fell. If you drill down 100 meters, you are breathing air from the time of the Roman Empire. If you drill down a kilometer, you're breathing air from a time before human civilization existed. And at Vostok, they drilled deeper than that. For decades, in conditions that tested the absolute limits of human endurance, teams of scientists bored a shaft straight down into the heart of the ice sheet. They retrieved cylinders of ice cores, that were over 3,000 meters long. When you look at one of these cores in a laboratory, it looks like a long, polished cylinder of glass. But if you look closely, you can see them. Millions of tiny suspended bubbles. These bubbles are the fossilized breath of the planet. They contain the carbon dioxide, the methane, and the dust of a world that no longer exists. By carefully crushing these samples in a vacuum and analyzing the gas that escapes, we can taste the air of the deep past. The Vostok core took us back 400,000 years. Later cores, like those from Dome C, took us back 800,000 years. It is the most complete, continuous, and high-resolution record of climate ever recovered. It is a vertical timeline preserved in the deep freeze, untouched by rot, untouched by erosion, waiting for us to learn how to read it. And when the scientists finally laid out the data from these cores, when they plotted the temperature and the carbon dioxide levels over the last nearly 1 million years, they did not see a straight line. They did not see chaos. They saw a heartbeat. The data from Vostok was not ambiguous. It was shocking in its clarity. When the scientists plotted the temperature of the Earth over the last 800,000 years on a graph, the line did not wander aimlessly. It did not look like the random, chaotic fluctuations of weather. It looked like a machine. The graph formed a perfect, repeating, and serrated shape. We call it the sawtooth. Imagine the teeth of a saw blade. One side of the tooth is long and gradual. The other side is short and steep. The long, gradual slope represents the freeze. For roughly 90,000 years, the Earth slowly, relentlessly gets colder. The ice sheets grow bit by bit, century by century, consuming the continents. The global temperature slides down into the depths of a glacial maximum. And then, the sudden break. The steep vertical side of the tooth. In a geological blink of an eye, perhaps only 10,000 years, the temperature shoots upward. The ice collapses. The world floods. The climate snaps from deep freeze to a warm, stable, interglacial period like the one we live in now. And then, almost immediately, the slow slide into the cold begins again. This pattern repeats over and over again, 8 times in the last 800,000 years. Every 100,000 years, the planet inhales the cold and then, briefly, exhales the warmth. It is a rhythm as steady as a metronome. It is a heartbeat. This discovery changed everything. It meant that the ice ages were not accidents. They were not caused by random volcanic eruptions or stray asteroids. They were cyclical. They were inevitable. Something was driving this cycle, something powerful enough to freeze a planet, yet precise enough to do it on a schedule that you could set a clock by. But the source of this rhythm was not on the Earth. You cannot find a 100,000-year cycle in the tectonic plates. You cannot find it in the ocean currents. The Earth is a chaotic place. It does not keep time like this. To find the clockmaker, we had to look away from the Earth entirely. We had to wait for a Serbian mathematician sitting in a prison cell watching the light of a candle to realize that the answer lay in the silent, mathematical perfection of the sky.
The answer to the riddle of the ice did not come from a glaciologist standing on a frozen peak. It came from a mathematician sitting in a prison cell. The year is 1914. The world is descending into the chaos of the First World War. While armies are mobilizing and empires are crumbling, a Serbian engineer and mathematician named Milankovich is arrested by the Austro-Hungarian authorities. He is detained as an enemy alien, taken from his honeymoon, and eventually confined in Budapest. But while the world outside his window was tearing itself apart with artillery and mustard gas, Milankovich did something extraordinary. He turned his back on the chaos of the present and looked deep into the silence of the past. He was granted a small mercy. He was allowed to work in the library of the Hungarian Academy of Sciences. He sat there day after day while Europe burned, armed with nothing but a fountain pen, stacks of paper, and a slide rule. He set himself a task that seems, even today, borderline impossible. He decided to calculate the climate of the Earth for the last 600,000 years. He did not have ice cores, he did not have supercomputers, he did not have the geological data we possess today. He had only the laws of physics. Milankovich believed that the Earth's climate was not a random system. He believed it was a machine driven by the energy of the sun. And if it was a machine, its movements could be calculated. He reasoned that if he could map the exact position of the Earth in relation to the sun for every single point in the deep past, he could determine exactly how much solar energy fell on the planet at any given latitude. It was a calculation of staggering complexity. He had to account for the gravitational pull of Jupiter and Saturn, the shifting mass of the Earth itself, and the subtle clockwork interactions of the entire solar system. He worked in solitude for years. He filled thousands of pages with dense, hand-written trigonometric equations. He mentally lifted the Earth out of its orbit and spun it backwards through time. He was constructing a mathematical ghost of the planet. And as the numbers began to align, as the pages filled up, a pattern began to emerge from the ink. It was not a chaotic scroll. It was a wave. Milankovich realized that the Earth does not travel through a void. It travels through a web of invisible forces. And these forces, these gravitational tugs from distant giants, were slowly, rhythmically altering the way our planet moves. He had found the gears of the great cosmic clock. Before Milankovich, geology was almost entirely a science of looking down. When scientists asked why the climate changed, they looked for answers in the mud. They looked at volcanoes, at shifting continents, at the circulation of the deep oceans. They assumed that the causes of Earth's history were contained within the Earth itself. They treated the planet as a closed system, a lonely ship drifting through a void. Milankovich shattered this illusion. He realized that to understand the fever and the chill of the planet, you cannot look at the patient. You have to look at the room the patient is standing in. He understood that the Earth is not a closed system. It is powered by a single external engine, the sun. Every joule of energy that drives the winds, flows the rivers, and grows the forests comes from that star. Therefore, the temperature of the Earth is determined by a very simple equation. How much sunlight do we receive, and where does it fall? For a long time, it was assumed that this relationship was constant. The sun burns steadily, the Earth circles it, the seasons come and go. But Milankovich saw the flaw in this static picture. He realized that the solar system is not a lonely place. It is a crowded room.
We share this space with giants, Jupiter and Saturn, gas behemoths with gravitational fields so immense they dwarf our own. And we share it with smaller rocky neighbors like Venus and Mars. Gravity is an invisible tether. It is weak, but it is infinite. It reaches across the vacuum. And so as the Earth travels around the sun, it is not tracing a perfect isolated line. It is being pushed. It is being pulled. It is being nudged by the gravity of Jupiter, tugged by the pass of Saturn. These forces are subtle. In a single year they amount to nothing. But time is the great magnifier. Over tens of thousands of years, these tiny rhythmic gravitational tugs accumulate. They begin to warp the path of our planet. They begin to tilt it. They begin to wobble it. Milankovich realized that the Earth's position in space is not fixed. It is dancing. And this dance changes the way the sunlight hits the surface. It does not necessarily change the total amount of heat the Earth receives, but it changes where that heat lands and, crucially, when. He identified 3 distinct movements, 3 different gears in the cosmic clock, each running at its own speed, each affecting the climate in its own unique way. When these gears align, they have the power to turn the Arctic sun away, to let the snow survive the summer, and to bury the world in ice. We tend to think of the solar system as a pristine, orderly machine, a model of clockwork perfection where the planets roll along in visible tracks, isolated and indifferent to one another. But gravity is a force that does not respect boundaries. It is infinite. It weakens with distance, but it never truly disappears. In the black silence of space, the Earth is not alone. It is surrounded by giants. Far beyond the orbit of Mars lies Jupiter. This is a planet so massive that it contains more than twice the material of all the other planets combined. It is a failed star, a colossal ball of gas with a gravitational field that reaches out across hundreds of millions of miles. Beyond it lies Saturn, another titan, ringing the solar system with its own immense pull. As the Earth races around the Sun at 67,000 miles an hour, it is constantly passing through the gravitational wake of these giants. Every time we pass Jupiter, we feel a tug. It is a subtle, almost imperceptible lurch, a gravitational whisper. If this happened once, it would mean nothing. But it happens again and again and again for billions of years. It is like pushing a child on a swing. One gentle push does very little, but if you push at the exact right moment, every single time the swing comes back, the energy accumulates. The arc goes higher. The movement becomes exaggerated. This is the principle of orbital resonance. Because of these constant rhythmic tugs from Jupiter and Saturn, the Earth's path through space is not stable. It is flexible. It breathes. The orbit stretches out, becoming long and elliptical, pulling us millions of miles further from the warmth of the sun. Then, slowly, under the influence of different alignments, it is squeezed back into a near-perfect circle. The Earth spins like a top, but under the pull of the moon and the sun, that top begins to wobble. Its axis nods up and down. This is the cosmic clockwork. It is a complex, chaotic, and beautiful dance of gravity. The Earth is being passed back and forth between the sun and the gas giants, a small rocky vessel caught in a gravitational tide. And Milankovich realized that this dance can be broken down into 3 distinct movements, 3 specific gears that drive the climate of our world. The first gear is the largest, the slowest, and the most powerful. It is the shape of the path itself. The first gear of the cosmic clock is the slowest, but it is the one that sets the tempo for the entire ice age. It is called eccentricity.
In our minds, and in the diagrams we see in school, the Earth's orbit around the Sun is drawn as a perfect circle, a stable, unchanging ring. But this is a simplification. The true path of the Earth is not a circle. It is an ellipse. It is an oval, like a circle that has been slightly flattened. And this shape is not fixed. It breathes. Over a vast cycle of roughly 100,000 years, the gravity of Jupiter and Saturn slowly pulls on the Earth. They stretch our orbit. The path transforms from a near-perfect circle into a long, elongated oval. And then, just as slowly, it snaps back. This is the stretch. Why does this matter? Because an orbit is not just a line in space. It is a measure of distance. When the orbit is circular, the Earth stays at a constant, comfortable distance from the Sun all year round. The heat is steady. But when the orbit stretches, when eccentricity is high, the Earth is forced to travel far out into the cold dark of space before swinging back in. At the furthest point of this long oval, we are millions of miles farther away from the Sun than usual. It is the difference between standing next to a fire and taking 2 large steps back. The total amount of solar energy reaching the planet drops. The winters become slightly longer. The summers become slightly weaker. The planet receives less fuel. And here is the key. This cycle, this stretching and relaxing of the orbit, takes exactly 100,000 years to complete. This matches the heartbeat we saw in the ice cores, the sawtooth graph from Vostok. The rise and fall of the great ice sheets beats in perfect synchronization with the stretching of our orbit. When the Earth is pulled far from the Sun, the ice grows. When the orbit becomes circular again, the ice recedes. This is the primary rhythm. The 100,000-year pulse of the ice ages is quite literally a map of our distance from the star that warms us. But distance alone is not enough to freeze a planet. The cold needs help. It needs to know where to strike. And for that, we need the second gear. The first gear, eccentricity, dictates how far we stand from the fire. But the second gear dictates something far more subtle and far more dangerous. It dictates the angle at which the light strikes our face. This is obliquity, the tilt. To understand this, you must picture the Earth not as a static globe on a desk, but as a spinning top. When a top spins fast, it stands perfectly upright. But as it slows, or as it is nudged by invisible forces, it begins to nod. It rocks back and forth, a slow, hypnotic oscillation relative to the floor. Our planet is that top. It is spinning at 1,000 miles an hour, suspended in the vacuum, and it is nodding. We are taught that the Earth is tilted at 23.5 degrees relative to the Sun. This is the magic angle. It is the reason we have seasons. When the northern hemisphere tilts toward the Sun, we have summer. When it tilts away, we have winter. It is the engine of our yearly calendar. But this number, 23.5, is not a constant. It is merely where we are right now. Over a cycle of 41,000 years, the Earth slowly rocks back and forth. The angle changes from a shallow 22.1 degrees to a steep 24.5 degrees. It seems like a trivial difference, a shift of just 2 degrees. On a protractor, it is barely visible. But on a planet, it is the difference between standing next to a fire and taking 2 large steps back. This brings us to the great paradox of the ice ages. If you were to ask someone what causes an ice age, they would likely say, very cold winters. It makes intuitive sense. If the winter is brutal, the world freezes. But Milankovich realized this was wrong. He understood a profound meteorological truth. Cold winters do not build glaciers. In fact, extremely cold winters are often dry. They starve the ice sheets of moisture.
The true architect of an ice age is not the winter. It is the summer. Consider the mechanics of a glacier. A glacier is born from snow. Every winter, snow falls on the high northern latitudes of Canada, Scandinavia, and Siberia. This is normal. The critical moment comes in July. When summer arrives, its job is to melt that snow. It must wipe the slate clean before the next winter arrives. If the summer is hot, the snow vanishes and the land remains green. But what happens when the Earth's tilt is low? What happens when the angle is shallow at 22.1 degrees? It means the summer sun does not climb as high in the sky. It stays low on the horizon. Its rays are weak, slanted, and diluted by the atmosphere. It offers light, but very little heat. In this scenario, the summer fails. The sun shines, but it is too weak to melt the previous winter's snow. The snow survives. It lingers through June, through July, through August. It sits on the ground, stubborn and white, reflecting the weak sunlight back into space. And then September comes. The next winter arrives. Fresh snow falls on top of the old unmelted snow. This is the seed of the Ice Age. It is a residue of winter that the summer was too weak to erase. Year after year, this leftover snow accumulates. The weight of the new layers presses down on the old, the snowflakes are crushed, they lose their air, they transform from white powder into granular substance called firn, and then under immense pressure, they fuse into solid blue ice. This happens over and over again for thousands of years. The pile grows higher. It begins to flow under its own weight. It swallows the valleys. It overtops the mountains. This is the power of the tilt. It is the 41,000-year cycle that controls the strength of the seasons. When the tilt is high, the seasons are extreme. Hot summers destroy the ice. When the tilt is low, the seasons are mild. Cool summers allow the ice to survive. This gear, this rocking of the planetary cradle, determines whether the snow melts or whether it builds a monument to the cold. But there is one final gear, a gear that is faster, stranger, and more chaotic than the others. A wobble that changes not just the seasons, but the stars themselves. The first gear stretches the orbit. The second gear rocks the axis. But the third gear is the most disorienting of all. It changes the very definition of our place in the stars. This is precession, the wobble. If you have ever watched a spinning top closely, you know that it does not just stand still. As it spins, the handle at the top traces a slow, lazy circle in the air. It gates. The Earth is doing exactly this. Right now, the North Pole points directly at a specific star, Polaris, the North Star. It is our anchor, the fixed point by which sailors have navigated for thousands of years. We assume it is permanent. It is not. Because of the gravitational pull of the sun and the moon tugging on the Earth's bulging equator, our axis is slowly twisting. The North Pole is drawing a massive circle in the sky. 12,000 years ago, our ancestors did not look up at Polaris. They looked up at a brilliant blue-white star called Vega. In another 12,000 years, our descendants will look up and see Vega again. Polaris will just be another random star in the drift. This cycle takes roughly 23,000 years. It is the fastest hand on the cosmic clock. But why does the direction of the axis matter for the climate? Why does it matter which star we point to? It matters because the Earth's orbit is not a circle. Remember the first gear, the stretch. The Earth has a point in its orbit where it is closest to the sun and a point where it is furthest away. Precession determines which season falls on which side of the orbit. This is critical. Right now, by a stroke of cosmic luck, the northern hemisphere has its winter when the Earth is closest to the sun. This makes our winters slightly milder than they should be. We are closer to the fire during the coldest months, but the wobble is turning. In roughly 10,000 years, the axis will flip. The northern hemisphere will have its winter when the Earth is at its furthest point from the sun, deep in the cold of space, and it will have its summer when it is closest to the roaring heat of the star. This creates a cycle of extremes. When precession aligns perfectly with eccentricity, it creates a superseason. It can make winters brutally cold and summers intensely hot. Or as the cycle turns, it can do the opposite. It can create mild winters and cool summers. And as we have learned, cool summers are the key. When the wobble aligns just right, it positions the northern hemisphere where the great land masses of Canada and Siberia lie. To receive the absolute minimum amount of summer solar energy, it robs the summer of its power to melt the snow. This is the third gear. It is the fine tuner. It is the frequency modulator that amplifies or cancels out the effects of the other two. Milankovich now had all the pieces. He had the stretch, 100,000 years. He had the tilt, 41,000 years. And he had the wobble, 23,000 years. Separately, they are just gentle nudges. But Milankovich realized that these cycles overlap. They weave together. And every so often, like the tumblers of a giant cosmic lock clicking into place, they all align in the same direction. And when they do, they open the door to the ice. Separately, these forces are weak. A slightly stretched orbit changes the sunlight by a fraction of a percent. A lower tilt cools the summer by a mere degree. A wobble shifts the calendar by a few weeks. On their own, they are nothing. They are background noise in the solar system. But Milankovich realized that time is a weaver. It takes these separate threads, the 100,000-year stretch, the 41,000-year tilt, and the 23,000-year wobble, and it braids them together. Most of the time, these cycles work against each other. The orbit might be stretching us away from the sun, but the tilt is high, giving us hot summers that melt the ice. They cancel each other out. The climate remains stable, the planet remains green. But once every 100,000 years, the gears align. The tumblers of the great cosmic lock click into place. It is a moment of constructive interference, a perfect storm of cold. Imagine the scenario. First, eccentricity reaches its maximum. The Earth's orbit is stretched into a long, thin oval. We are pulled millions of miles away from the furnace of the sun. Second, precession turns the axis. It dictates that the northern hemisphere experiences its summer at the exact moment the Earth is at that furthest, coldest point of the oval. The summer sun is distant and small. Third, obliquity drops. The Earth stands nearly upright. The tilt decreases to its minimum, meaning that distant, weak summer sun strikes the high latitudes at a shallow, glancing angle. It is a triple blow. Distance, timing, and angle all conspire to rob the north of its heat. The solar energy falling on the Canadian Arctic or the Scandinavian highlands drops precipitously. It falls below the critical threshold. The snow that falls in winter does not melt in summer. It survives. It waits for the next winter and the next. Milankovich sat in his cell and calculated these curves by hand. He drew a graph that predicted exactly when these moments of alignment occurred in the past. He predicted the ice ages before anyone had ever drilled an ice core. He saw the mathematical inevitability of the cold. But there was still a problem, a gap in the theory that nagged at him. When you do the math, even this perfect storm of orbital alignment only reduces the total sunlight by a small amount. It is a significant drop, yes, but on paper it is not enough to freeze a planet.
It is not enough to build ice sheets 3 kilometers thick. The math says the Earth should get slightly cooler. The geology says the Earth turned into a frozen wasteland. There was a missing piece. The orbital cycles were the trigger, but they were not the bullet. Something else had to take that initial subtle cooling signal and amplify it. Something on the Earth itself had to hear the whisper and turn it into a scream. The math was perfect. The curves aligned. Milankovich had successfully mapped the heartbeat of the solar system. But there was a ghost in the machine, a discrepancy that haunted the theory for decades. When physicists calculated the actual loss of heat caused by these orbital shifts, the numbers were underwhelming. Even in the worst-case scenario, the perfect storm of tilt, wobble, and stretch, the total reduction in solar energy reaching the Earth is remarkably small. It is equivalent to turning down a dimmer switch by a tiny fraction. It should have caused a mild cooling, a few degrees drop in the Arctic, a slightly longer winter. It should not have buried North America under 3 kilometers of ice. It was a paradox. The orbital cycles were a whisper, but the climate record showed a scream. The planet was reacting with a violence that the solar input could not explain. It was as if a gentle tap on the brakes had sent a car spinning off the road. This led scientists to a profound realization. The Earth is not a passive rock. It is not a dead ball of stone that simply sits in the sun and accepts whatever heat it is given. The Earth is a reactive system. It is a machine with its own internal gears, its own levers, and its own hidden reserves of power. The orbital cycles are merely the trigger. They are the key that turns the ignition. But the engine, the force that actually drives the ice age, lies within the planet itself. We call these feedback loops. They are the mechanisms that take a small change and amplify it, doubling it, tripling it, until it becomes a runaway force. Milankovich had found the rhythm, but to understand the freeze, we have to understand how the Earth took that subtle cosmic signal and weaponized it against itself. The planet has two great amplifiers, two mechanisms that it uses to turn the cold into the deep freeze. One is made of light, the other is made of air. And the first amplifier works like a mirror. The first amplifier is built on a simple principle of color. Imagine walking across a dark asphalt parking lot on a blistering summer day. The ground is hot. It radiates heat through the soles of your shoes. Now imagine stepping onto a patch of white concrete. It is cool. This is the albedo effect. It is a measure of reflectivity. Dark surfaces, deep blue oceans, green pine forests, brown soil are hungry. They absorb the sun's energy. They drink the light and convert it into heat, warming the air above them. A planet covered in forests and oceans wants to stay warm. White surfaces are the opposite. Snow and ice are nature's mirrors. They do not absorb heat, they reject it. They bounce the sunlight straight back up through the atmosphere and out into the cold vacuum of space. A planet covered in ice wants to stay cold. This creates a dangerous feedback loop. When the Milankovich cycles align, when the orbit stretches and the tilt drops, the summers in the north become weak. A few patches of snow in the Canadian highlands or the Scandinavian mountains manage to survive through July and August. At first, these patches are insignificant, tiny dots on a dark map. But these dots are powerful because they are white. They reflect the weak summer sun. The air immediately above them cools down. This local cooling helps the snow patch survive and encourages fresh snow to fall around its edges. The white patch grows. As it expands, it acts like a growing mirror. It reflects more sunlight. The region gets colder. The colder it gets, the more it snows. The more it snows, the larger the mirror becomes. This is the ice albedo feedback. It is a self-fulfilling prophecy. Once the snow cover expands beyond a certain critical point, perhaps covering the Hudson Bay or the Baltic Sea, the process becomes unstoppable. The planet stops fighting the cold and begins to actively manufacture it. The great ice sheets of the northern hemisphere were not just frozen water. They were continent-sized shields. At the height of the last ice age, the vast whiteness of North America and Eurasia was reflecting enormous amounts of solar energy away from the Earth. The planet was effectively turning away from the fire. It was rejecting the very energy that could have saved it. This mechanism explains how a small drop in sunlight can trigger a local freeze. It explains the growth of the ice. But the ice ages were not local. They were global. When the north froze, the south froze too. The tropics dried out. The entire planet cooled in unison. A mirror in Canada cannot cool the jungle in the Amazon. For the cold to conquer the entire globe, the Earth needed a second amplifier. It needed a way to transmit the signal from the ice sheets to the rest of the world. It needed to change the air itself. The mirrors of ice explain why the North froze, but they do not explain why the whole world followed. When the glaciers marched across Canada, the jungles of the Amazon also cooled. The deserts of Africa changed. The entire planet from pole to pole entered a synchronized chill. A local mirror cannot do this. To change the temperature of the entire globe, you have to change the atmosphere itself. You have to thin the blanket.
This brings us to the second great amplifier, the thief. That thief is the ocean. To understand this mechanism, you only need to think of a bottle of soda. If you leave a bottle of soda out in the hot sun, it goes flat quickly. The gas escapes. But if you keep it ice cold, the gas stays trapped in the liquid. Cold water holds more gas than warm water. It is a fundamental law of physical chemistry. As the Milankovich cycles triggered that first subtle cooling in the north, and as the white mirrors of ice began to reflect the sun, the temperature of the global oceans dropped. And as the water cooled, it became hungry. It began to inhale. The ocean started to suck carbon dioxide out of the atmosphere. Billions of tons of heat-trapping gas were pulled from the sky and dissolved into the waves. As the CO2 levels in the atmosphere dropped, the greenhouse blanket grew thinner. The planet lost its ability to hold on to heat. This made the world colder, which made the oceans colder, which made them absorb even more gas. It was a downward spiral into the deep freeze. But the ocean had another more active way of burying the sky. It used life. As the ice sheets grew on land, they ground the bedrock into a fine, mineral-rich dust. This dust was blown by the fierce glacial winds out over the oceans. It acted as a massive dose of fertilizer. The surface waters exploded with life. Phytoplankton, microscopic plants, bloomed in vast, swirling clouds that could be seen from space. These tiny creatures drank the remaining carbon dioxide from the air to build their bodies, and when they died, they did not rot on the surface. They sank. A constant marine snow of dead carbon drifted down into the crushing darkness of the abyss. It settled on the seafloor, locking that carbon away for thousands of years.
The ocean had effectively robbed the atmosphere of its insulation. This is why the Vostok ice cores show that carbon dioxide and temperature move in perfect lockstep. When the CO2 goes down, the temperature crashes. The orbital cycles were the trigger. The ice sheets were the mirrors. But it was the ocean silently stealing the sky that turned a regional cold snap into a global ice age. The trap was now fully set. The trigger, the mirror, and the thief had worked in unison. The world was ready for the long white winter. The trap was sprung. The trigger had been pulled by the orbit. The mirror was reflecting the sun, and the ocean was burying the heat. Now, the physical transformation of the continent began. We often think of an ice age as a time of endless blizzards, a stormy, chaotic whiteout. But the growth of the great ice sheets was likely something far more quiet and far more terrifying. It was a slow, inexorable suffocation. It began in the high ground, in the Keewatin Plateau of Canada, in the mountains of Scandinavia. The snow simply stopped melting. Year after year, the layers built up. 10 feet, 50 feet, 100 feet. At a certain critical thickness, the physics of the snow changed. The crystals at the bottom were crushed under the immense weight of the fresh snow above. They fused together, squeezing out the air, turning from white fluff into a dense blue plastic rock. The ice began to flow. It behaved like a slow-motion river of molasses. Guided by gravity, lobes of ice began to creep down from the highlands, spilling into the valleys, burying the forests, and filling the lake beds. These were not the glaciers we see today, clinging to the sides of mountains. These were ice sheets, continent-sized domes that created their own topography. The greatest of them all was the Laurentide ice sheet. It grew to cover nearly all of Canada and the northern United States. It swallowed the Great Lakes. It buried the sides of modern-day Chicago, New York, and Boston. At its center, over Hudson Bay, the ice was not a thin crust. It was a dome over 3 kilometers high. Imagine standing at the base of a wall of ice that stretches up into the stratosphere higher than the Rocky Mountains. It was a feature so massive that it altered the rotation of the Earth. It physically blocked the jet stream, forcing the winds to flow around it, changing the weather patterns of the entire northern hemisphere. In Europe,
The Fennoscandian ice sheet descended from the north, burying the British Isles in Scandinavia, reaching all the way to Berlin and Moscow. These were the white giants. They were heavy, cold, and indifferent. They ground the surface of the earth down to the bedrock, acting like colossal sheets of sandpaper, erasing river valleys and carving out the landscapes we walk on today. And as they grew, they did something else. They grew heavy. So heavy, in fact, that they began to warp the crust of the earth itself. Water is heavy. Anyone who has ever carried a full bucket knows this. A single cubic meter of water weighs a ton. Now imagine a layer of water frozen solid, stretching for thousands of miles and stacked 3 kilometers high. The weight is astronomical. It is a burden so immense that the Earth's crust, the solid rock we think of as immovable, could not withstand it. It bent. We tend to think of the ground as a rigid platform. But on geological scales, the Earth's crust is more like a raft floating on a thick, viscous sea of molten rock, the mantle. When you place a heavy weight on a raft, it sinks. Under the crushing load of the Laurentide and Fennoscandian ice sheets, the continents of North America and Europe literally sank.
The solid rock was pushed down, depressed by nearly a kilometer into the Earth's mantle. The ice created its own basins. It turned convex landscapes into concave bowls. The Hudson Bay in Canada is a ghost of this pressure. It is a depression formed by the very center of the ice dome, where the weight was greatest. This sinking was not a rapid event. It was a slow, grinding surrender of the rock. And the recovery has been just as slow. This is the most haunting legacy of the ice ages. The ice has been gone for 10,000 years, but the land is still remembering the weight. It is still springing back. We call this isostatic rebound. Right now, as you listen to this, the land in Scandinavia and northern Canada is rising. It is lifting out of the sea at a rate of roughly a centimeter a year. The ancient beaches of the Vikings are now far inland, lifted high above the waves by the slow, groaning recovery of the crust. The planet is still healing from the bruise. But while the continents were sinking under the weight of the ice, the rest of the world was changing in an equally dramatic way. The water to build these white giants had to come from somewhere. The ice sheets were not created from nothing. They were stolen from the sea. And as the ice grew, the oceans shrank. The map of the world was being redrawn. To build a mountain of ice 3 kilometers high, you have to empty the ocean. The sheer volume of water locked up in the Laurentide and Fennoscandian ice sheets was staggering. It was enough water to lower the global sea level by 120 meters. That is the height of a 40-story skyscraper. If you were to stand on a beach during the last glacial maximum, the ocean would not be lapping at your feet. It would be gone. It would be a blue line on the distant horizon, miles away, across a windy, salt-crusted plain. The familiar map of the world, the shapes of the continents we know from school globes, was erased. The British Isles were not islands. They were the highlands of a vast, low-lying European peninsula. You could walk from London to Paris or from Amsterdam to Newcastle without ever getting your feet wet. You would be walking across Doggerland, a rich, grassy tundra teeming with herds of mammoth and reindeer, a land that is now buried beneath the cold waves of the North Sea. In the east, Asia and North America were not separated by the sea. The Bering Strait, that narrow strip of water between Russia and Alaska, was a wide, solid land bridge called Barynkia.
It was an intercontinental highway, a grassland corridor thousands of kilometers wide that allowed life to flow between the worlds. The planet was physically larger. The continental shells were exposed to the air. It was a drier, dustier world. With so much water locked in ice, the global rainfall plummeted. The lush rainforests of the equator shrank into isolated pockets, replaced by dry savannas. The world was not just cold, it was thirsty. And in this drained, expanded world, life found a way. It did not just endure the cold, it used the new geography to move. The ice had closed the northern routes, but the falling seas had opened the path for the greatest journey of all. The ice sheets were walls. They were unscalable, white fortresses that blocked the northern horizon. But in stealing the ocean, they had inadvertently built bridges. For the life of the Pleistocene, the Ice Age was not a time of paralysis. It was a time of unprecedented mobility. The world was colder, yes, but it was also connected in a way that it is not today. The isolation of the continents was broken. The great land masses of Eurasia and the Americas, usually separated by the churning, freezing waters of the Pacific, were fused together by the Bering Land Bridge. But to call it a bridge is to diminish it.
It was a subcontinent, a landmass as wide as modern-day France, a lost country that existed for thousands of years before drowning again. And it was not a barren sheet of ice. This is the great misconception of the Ice Age. We imagine a world buried in deep snow, but because so much water was locked in the glaciers, the air was incredibly dry. In many places, it simply did not snow enough to build glaciers. Instead, a unique, now extinct ecosystem stretched across the top of the world. It was called the Mammoth Steppe. Imagine a grassland that stretches unbroken from the coast of Spain across the entirety of Russia, over the land bridge and deep into the Yukon of Canada. A single vast wind-swept ocean of dry, nutritious grass and sagebrush. It was cold, arid and dusty. The wind never stopped blowing, but in the summers, under the 24-hour sunlight of the high latitudes, this steppe exploded with productivity. It supported a density of animals that rivals the African Serengeti of today. Herds of woolly mammoths, creatures perfectly engineered for this cold, dry world, grazed alongside woolly rhinoceroses. Massive herds of steppe bison thundered across the plains, hunted by cave lions and scimitar-toothed cats. It was a landscape of giants, a Serengeti of the ice. And following these herds, moving quietly through the tall grass, was the most dangerous predator of them all. US. The Ice Age did not stop human migration. It accelerated it. The lower sea levels opened the coastal routes. The green corridors that appeared between the ice sheets during brief warm spells acted as funnels, drawing populations northward. For our ancestors, the Ice Age was an invitation. The drying of the world forced them out of the shrinking forests and onto the open plains. The cold forced them to innovate, to master fire, to sew complex clothing, to build shelters. They followed the Mammoth Steppe. They walked from Siberia into Alaska, not knowing they were crossing between continents, simply following the grass and the meat. They lived on the land bridge, not just as travelers, but as residents. Genetic evidence suggests humans may have paused in Beringia for thousands of years. A Beringian standstill, isolated by the ice walls to the east and the west, evolving into the distinct genetic lineage that would eventually populate the Americas. The cold was a forge. It tempered the animals and the people, stripping away the weak, favoring the adaptable. For millions of years, this was the rhythm. The ice grew, the ocean shrank, the bridges opened, and life moved. Then the ice melted, the oceans rose, the bridges closed, and life evolved in isolation. It was a perfect repeating pulse, a 41,000-year heartbeat that governed migration, evolution, and extinction. But then, something strange happened. The rhythm broke. The cosmic clock skipped a beat. About 1 million years ago, the pattern that had ruled the Earth for eons suddenly shifted. The winters got longer, the ice got thicker, and the cycle slowed down. For nearly 2 million years, the Earth was a predictable machine. If you look at the deep sediment records from the ocean floor, the pattern is clear, rhythmic, and unbreakable. The planet pulsed to a 41,000-year beat. This was the cycle of the tilt. As the Earth rocked back and forth on its axis, the ice sheets grew and shrank in perfect sympathy. It was a symmetrical world. The ice ages were frequent, but they were relatively mild. The warm periods were frequent, but they were modest. It was a world of balance. But then, about 1 million years ago, something in the machinery broke.
This event is known to science as the mid-Pleistocene transition. It is one of the most baffling mysteries in the history of our planet's climate. Without warning and without any obvious external cause, the heartbeat of the Earth slowed down. It skipped a beat, and then another. The 41,000-year cycle faded away. In its place, a new, much longer, and much more brutal rhythm emerged. The cycle stretched to 100,000 years. This was not just a change in timing, it was a change in intensity. Under the old regime, the ice sheets were like shallow tides, washing over the northern lands and then quickly retreating. But under the new 100,000-year regime, the ice became aggressive. It became stubborn. The glaciers refused to melt when the tilt said they should. They persisted through the warm orbital cycles. They grew thicker, colder, and heavier, piling up for 90,000 years at a time, reaching heights and volumes that the planet had never seen before. And when they finally did collapse, the termination was violent and rapid, leading to the serrated sawtooth pattern we saw in the Antarctic ice cores. Here is the true mystery. Here is the thing that keeps scientists awake at night. The sun did not change. The Milankovich cycles, the stretch, the tilt, the wobble, continued exactly as they always had. The cosmic clockwork did not slow down. The signal from space was identical. But the Earth stopped listening. It stopped reacting to the strong, clear signal of the tilt and started dancing to the much fainter, much more subtle rhythm of eccentricity. It is as if a radio suddenly ignored the loud, clear broadcast on the main frequency and tuned itself into a faint, ghostly whisper of static in the background, amplifying it until it drowned out everything else. Why? Why did the planet decide to plunge itself into deeper, longer, and more severe winters? Why did the ice become harder to kill? The answer, we believe, lies not in the sky, but beneath the ice itself. It lies in the friction between the glacier and the stone. The planet changed its skin. The answer to the riddle of the 100,000-year cycle lies in the dirt. To understand why the ice became invincible, we have to look at what it was sitting on. Before the ice ages began, the continents of North America and Europe were very different places. They were covered in a thick, deep layer of loose soil, decomposed rock, and ancient sediment. Geologists call this regolith. It was the accumulated dust of millions of years of weathering. When the first glaciers formed, roughly 2 million years ago, they sat on top of this regolith. Think of loose soil as a layer of ball bearings. It is slippery. When the ice sheets grew on top of this soil, they were mobile. They slid easily. They spread out thin and fast. And because they were thin and because they were constantly moving, they were vulnerable. When the 41,000-year tilt cycle brought a slightly warmer summer, these thin, slippery ice sheets collapsed quickly. They melted away. But glaciers are not just frozen water. They are the most powerful bulldozers in nature. Every time the ice advanced and retreated during those early cycles, it acted like a giant sheet of sandpaper. It scraped,
it gouged, it pushed the regolith into the oceans. For 1 million years, the ice was slowly stripping the continents naked. And then, about 1 million years ago, the job was finished. The loose, slippery soil was gone. The Canadian Shield and the Scandinavian mountains were scoured down to the hard crystal and bedrock. The physics of the ice changed instantly. Now the glaciers were not sitting on slippery soil. They were sitting on rough, high-friction stone. The ice stuck.
It gripped the rock. This increased friction meant the ice sheets could no longer slide easily. Instead of spreading out thin, they began to grow up. They piled higher and higher, becoming thicker, steeper, and colder. They became fortresses of ice. Because they were so thick and cold, they developed a new resistance. When the 41,000-year tilt cycle came around to warm the planet, these new sticky ice sheets simply ignored it. The summer warmth was not enough to melt the fortress. The ice survived the weak heat and kept growing. It began to skip the beat. It waited. It grew for another 40,000 years, and another, until it reached a size so unstable, so massive, that only the most powerful alignment of all, the 100,000-year eccentricity cycle, could finally bring it down. The planet changed its rhythm because it changed its skin. By stripping away the soil, the Earth inadvertently built a trap for itself, allowing the ice to grow into the monsters that defined the last 1 million years. But even monsters have a breaking point. And when the 100,000-year cycle finally hits, the end of the ice age is not a slow fade, it is a collapse. For 90,000 years, the ice builds. It is a slow, patient accumulation, a relentless subtraction of water from the ocean and heat from the air. But the end of an ice age is not slow, it is not patient, it is a collapse. In the language of paleoclimatology, this event is not called a warming, it is called a termination. The word implies violence, and it is appropriate when the 100,000-year cycle finally aligns for heat, when the orbit stretches, the tilt rises, and the wobble points the North Pole toward the sun. The fortress of ice is attacked from all sides. The sun strikes with renewed fury. The carbon dioxide released from the warming southern oceans floods the atmosphere. The ice sheets, now dangerously high and unstable, begin to rot. They do not simply trickle away, they shatter. Vast lakes of meltwater, some the size of inland seas, pool on top of the glaciers. The pressure grows until the ice cracks, sending millions of gallons of water plunging down vertical shafts called moulins to the bedrock below. This water acts as a lubricant. The friction that held the ice in place is destroyed. Whole sectors of the ice sheet destabilize. They slide into the ocean in armadas of icebergs, a process known as a Heinrich event. These armadas are so vast, they choke the North Atlantic, changing the currents, altering the weather of the entire globe. On land, the melting is catastrophic. Dams made of ice holding back trillion-ton lakes burst. The resulting megafloods are beyond modern comprehension. Walls of water hundreds of feet high tear across the landscape, stripping the soil down to the bedrock in a matter of days. The scablins of Washington state are the scars of one such violent release. And the ocean? The ocean rises. It does not creep up inch by inch. It surges in periods known as meltwater pulses. The global sea level can rise meters in a single human lifetime. The continental shelves are drowned. The land bridges of Beringia and Dagaland are swallowed by the waves. The map of the world is furiously redrawn. Islands are born. Peninsulas are severed. This is the Great Melt. It is the steepest line on the sawtooth graph. A 90,000-year winter is undone in just a few thousand years of chaotic, wet, and violent spring. And when the water finally settles, when the ice has retreated to the poles and the coastlines have stabilized, a new world is revealed. A warm, wet, and incredibly stable world.
A world that would allow a wandering species of primate to stop running, to plant a seed, and to build a wall. The violent spasms of the meltwater floods eventually faded. The sea levels stopped rising. The coastlines, which had been moving inland for millennia, finally found their place. And then, about 11,700 years ago, the Earth did something it had not done in a very long time. It settled down. For the previous 2 million years, the climate had been a roller coaster. It was a chaotic, jagged line of freezing dips and feverish spikes. The weather was a force of constant, unpredictable change. A human being born in one century might live in a lush grassland, while their grandchildren might struggle in a dust bowl. But the new epoch, the Holocene, was different. If you look at the climate graph for the last 10,000 years, it is not a jagged line. It is almost perfectly flat. It is a plateau of warmth, a long, stable, and golden afternoon in the history of the planet. This stability is the Holocene exception, and it is the single most important geological fact in the history of our species. Consider the timing. Anatomically modern humans have walked this earth for at least 300,000 years. We have had the same brains, the same hands, the same capacity for language and invention for all that time. But for 95% of our existence, we built nothing permanent. We did not plant crops. We did not build cities. We lived as nomads, small bands of hunters moving with the herds, forever reacting to a world that refused to stand still. We were smart, but we were at the mercy of the Milankovich chaos. You cannot plant a farm if the rain patterns shift every generation. You cannot build a city if the sea level rises a meter every decade. And then the Holocene began. The climate locked into a narrow, predictable range. The rains became reliable. The seasons became trustworthy. And instantly, everywhere around the globe, independently, humans stopped running. We planted seeds in the Fertile Crescent. We cultivated rice in China. We built temples in the Americas. We invented writing, mathematics, and civilization. Everything we are, everything we have built, from the first mud brick to the International Space Station, is built on this single, fragile foundation of climate stability. We are the children of the Holocene. But when scientists look closer at this golden age, they get nervous. Because when they compare the Holocene to the previous warm periods, the other gaps between the ice ages, it looks strange. Usually, the interglacial periods are short. They are sharp peaks. The world warms up quickly, stays warm for a few thousand years, and then almost immediately begins the long slide back into the cold. By all the rules of the Milankovich cycles, the Holocene should have ended thousands of years ago. The peak has passed. The orbital geometry that caused the Great Melt has faded. The 65th parallel is receiving less sun. According to the cosmic clock, the party should be over. The ice should be returning. The glaciers should be creeping back down from Baffin Island in Norway right now. But they are not. The long summer continues. The pendulum seems stuck. And this leads us to the most unsettling question of all. Is this stability natural, or have we, without knowing it, broken the clock? If we were to follow the strict instructions of the cosmos, if we were to obey the gravitational laws that have governed this planet for the last 1,000,000 years, our golden age should be over. We are living on borrowed time. When astrophysicists look at the current position of the Earth, the numbers are unambiguous.
The gears of the Milankovich machine are turning towards the cold. The tilt of the Earth is decreasing. It is slowly straightening up, robbing the summers of their intensity. The wobble, the precession of the equinoxes, has moved the northern hemisphere's summer further away from the sun. The orbit is shifting. By every mathematical metric, the interglacial window is closed. The solar energy falling on the critical skylights of the Arctic, the 65th parallel north, is dropping. In fact, the solar radiation in the Arctic today is almost exactly the same as it was 115,000 years ago. And 115,000 years ago was the start of the last ice age. So where is the ice? The truth is the planet did try to return to the cold. It tried to follow the cycle. About 5,000 years ago, the peak warmth of the Holocene ended. The Earth entered a period known to geologists as the Neoglacial. It was a slow, stuttering slide downward. The tree lines in Siberia retreated south. The glaciers in the Swiss Alps and Norway woke from their slumber and began to creep down the valleys, burying ancient forests that had grown during the warm times. This cooling trend reached its climax very recently. We call it the Little Ice Age. From the 14th to the 19th century, the world shivered. It was a time when the Thames River in London froze solid, so thick that fairs were held on the ice. It was a time when the Viking colonies in Greenland, which had farmed green pastures for centuries, starved and vanished as the sea ice closed in. It was a time of famine and failed harvests across Europe. This was not a fluke. This was the beginning. It was the first stumbling step down the long slope into the next glacial maximum. The planet was responding to the Milankovich signal. The mirrors were trying to form. The ocean was trying to inhale. The system was working exactly as it always had. But then, abruptly, the cooling stopped. In the blink of a geological eye, the trend reversed. The slide into the cold didn't just halt, it shattered. The temperature didn't just level off, it rocketed upward. The glaciers that had been advancing during the Little Ice Age didn't just retreat, they began to vanish. The Arctic sea ice, which should be thickening right now, began to thin. The cosmic clock is still ticking. The gravity of Jupiter is still pulling. The tilt is still dropping. The signal for winter is being broadcast loud and clear from the solar system. But the Earth is no longer listening. Something has jammed the gears. A new force has entered the equation. A force powerful enough to override the gravity of the gas giants and the geometry of the sun. And this force did not come from the stars. It came from the ground. It came from the fires of a single species that learned how to unlock the carbon of the Carboniferous. The force that stopped the ice did not come from the sky. It came from the ground. For millions of years, the carbon of the ancient world had been safely buried. The forests of the Carboniferous, the plankton of the Jurassic oceans, they had all been locked away in the dark, turned into coal and oil. They were the planet's sleeping ghosts. And then, in a geological microscond, one species decided to wake them up. We call it the Industrial Revolution, but in the language of the Earth, it was a carbon pulse. We dug up the fossilized sunlight of 300 million years and we released it back into the atmosphere in the span of 2 centuries. We took the carbon cycle, a process that usually operates on the scale of millennia, and we accelerated it to the speed of an explosion. The effect on the Milankovich mechanism was profound. Remember the delicate balance required to start an ice age. The orbit stretches to cool the Earth. The tilt drops to weaken the summer. But these forces are subtle. They rely on the atmosphere being thin enough to allow the heat to escape. Scientists have calculated a specific threshold, a magic number, for the inception of a glacial period. To start an ice age, the carbon dioxide levels in the atmosphere need to be below 280 parts per million. For the last 10,000 years, we hovered right at that edge. The planet was primed. The door to the ice was unlocking. But then, we began to burn. We pushed the number past 280, then past 300, then 350.
Today, we are pushing past 420 parts per million. We have not just nudged the thermostat, we have smashed it. The concentration of heat-trapping gas in our atmosphere is now higher than it has been for at least 3 million years. We have created an atmosphere that belongs to the Pliocene epoch, a time when the Americas were not yet connected and trees grew near the South Pole. This immense layer of carbon acts as a shield. It intercepts the weak summer sun, traps its heat, and refuses to let it go. It completely overrides the cooling signal from the orbit. The gravity of Jupiter is still tugging. The axis is still tilting, but it no longer matters. The signal is drowned out by the noise of our own emissions. We have done something that no other species has ever done. We have canceled an ice age. This is not a metaphor. Based on the orbital cycles alone, the Earth should have begun its slow descent into the next glacial maximum within the next 1,500 years. The ice sheets should be gathering their strength right now. But because of the carbon we have already emitted, that future is gone. The next ice age has been postponed, perhaps for 50,000 years, perhaps for 100,000. Some models suggest that if we burn all the remaining fossil fuels, we will not just postpone the ice, we will end the cycle entirely. We could push the planet into a state so hot that the ice sheets of Greenland and Antarctica collapse completely, removing the mirrors from the system forever. We have entered a new epoch. The Holocene is over. We are now living in the Anthropocene. This is the age where the dominant geological force is not the volcano, not the asteroid, and not the orbit. It is us. We have seized the controls of the planetary machine. We have stopped the clock. But we do not fully understand the vehicle we are driving, and we have jammed the accelerator to the floor. We have bought ourselves a long summer. But the question remains, what happens to a planet that is designed to freeze when it is forced to burn? We have purchased a reprieve, a long summer. On the surface, this sounds like a victory. Humanity is a tropical species. We evolved in the warmth of Africa. We have no fur, no blubber. We despise the cold. To have stopped the glaciers, to have prevented the crushing weight of the ice from burying our northern cities, feels like the ultimate triumph of intelligence over geology. But this victory is a dangerous illusion. We have not just stopped the pendulum, we have cut the cord. And a planet without a pendulum does not necessarily find balance. It finds chaos. By pushing the carbon dioxide levels beyond the threshold of the last 3 million years, we are steering the planetary vessel toward a state that scientists call House Earth. This is a world where the feedback loops we discussed, the mirrors and the thieves, begin to work in reverse. As the Arctic warms, the white ice melts, revealing the dark, hungry ocean beneath. This dark water absorbs more heat, which melts more ice. The mirror shatters. As the permafrost in the frozen north thaws, it releases the carbon that has been locked in the frozen mud for millennia. The thief returns the stolen goods. The planet begins to amplify the heat just as efficiently as it once amplified the cold.
If this continues, we are not looking at a stable, warm Holocene. We are looking at a return to the Eocene. Imagine a world perhaps only a few centuries or millennia from now where the ice caps have vanished completely. Antarctica, the white continent, becomes green. Forests of beech and fern grow on the shores of the Southern Ocean, just as they did 50 million years ago. The Arctic Ocean becomes a tepid, swampy sea, teeming with azolla and algae. In this world, the sea level is not measured in inches. It is 70 meters higher than it is today. The coastlines of the modern world, Florida, Bangladesh, the Netherlands, the great deltas, are memories buried under the blue weight of the expanding ocean. But the true cost of the long summer is not the heat or the water. It is the loss of the rhythm. The Milankovich cycles, for all their brutality, provided a script. They provided a predictable, oscillating stability. The ecosystem knew the rules. The forests migrated north, then south. The animals adapted. In the hothouse Earth, the script is burned. The weather becomes violent and erratic, fueled by the immense thermal energy trapped in the atmosphere. Storms become planetary in scale. Droughts become semi-permanent features of the continents. The ocean currents, the great conveyor belts that move heat around the globe, may stall or reverse. We have traded the orderly, rhythmic ticking of the cosmic clock for the unpredictable, feverish shaking of a broken machine. And yet, the Earth itself, the rock, the water, the air, is patient. The carbon pulse we have released is massive, but it is finite. The fossil fuels will run out. The pulse will end. And then the deep, slow processes of geology will begin the cleanup. It will take time, an unimaginable amount of time, 10,000 years, 50,000 years, perhaps 100,000 years. The silicate rocks of the mountains will slowly weather, reacting with the CO2 in the rain, scrubbing the carbon from the sky, molecule by molecule, and washing it back into the sea to be locked away in limestone. The fever will break, the atmosphere will thin, and when the carbon is finally gone, the signal will still be there. The gravity of Jupiter will still be pulling. The axis will still be tilting. The sun will still be shining on the high Arctic. The Milankovich cycles are not dead. They are merely waiting. They are the patient heartbeat of the solar system, waiting for the noise of the Anthropocene to fade so they can resume their work. The ice will return. It may take 500,000 years, but the white giants will walk again. Because the Earth is not a static object. It is a living, breathing system. And we are just a momentary fever in its long, deep dream. Let us pull back. Let us leave the surface of the Earth. Let us rise above the smoke of the Anthropocene, above the melting glaciers, above the noise of our civilization. Let us travel out into the quiet blackness of space, to a point where the Earth is just a marble of blue and white suspended in the void. And now let us speed up time. If we were to watch the last 1,000,000 years of our planet unfold into time-lapse, we would not see a rock. We would not see a static map. We would see an organism. We would see the great white cap of the North Pole growing, flowing south like spilled milk, swallowing Canada, burying Europe, turning the planet white. And then we would see it shrink, pulling back to the sea, revealing the green and brown of the land. Expand, contract, expand, contract. It happens rhythmically, once every 100,000 years. It looks exactly like a chest rising and falling. It looks like a lung filling and emptying. The ice ages are not a disease. They are not a mistake. They are the respiration of the planet.
For the last 1,000,000 years, the Earth has been breathing. It inhales the cold and it exhales the warmth. It draws the ocean onto the land as ice and then releases it back as water. This rhythm is the pulse of the solar system itself. It is the gravity of Jupiter tugging at our orbit. It is the nod of the axis toward the sun. It is the silent silver machinery of the cosmos driving the breath of our world. And we are the creatures of the exhalation.
We have built our cities, written our histories, and lived our entire collective existence in the brief, warm pause between two breaths. We are the children of the interglacial. We assume that the summer is eternal simply because our lives are so short. But the Earth operates on a different timescale. It does not measure time in years or centuries or even dynasties. It measures time in cycles, in wobbles, in orbits. The silence of the Earth is not an emptiness. It is a patience. It is the patience of a mountain waiting for the ice to return and grind it into dust. It is the patience of the ocean waiting to reclaim the shore. It is the patience of a planet that knows with mathematical certainty that the winter will come again. The carbon we have pumped into the air is a disruption. It is a fever, but it is temporary. The rock will absorb it. The ocean will hide it, and eventually the fever will break. And when it does, the great gears of the sky will still be turning. The wobble will still be shifting the stars. The orbit will still be stretching into the dark. The signal will still be there. And the Earth, slowly, peacefully, will begin to inhale once more. So as you lie here tonight, safe in the warmth of this long, beautiful summer, remember the rhythm. Listen to the silence. It is not the silence of the dead. It is the deep, steady, and eternal breathing of the world. Good night.